Hey everybody, Mr. Gibson here. This is the video just simply going over the summary page for your Explain 2 interactive notes. So I'm going to make this as quick as possible because there's a lot of little matching and tiny little questions here, so I don't want to take too much of your time. Number one, the electrons that are not in the highest energy level, instead they're on the inner energy levels, are called the inner shell electrons. Okay. Number two, a measure of how easy it is to add an electron to an atom, or how much an atom wants to gain an electron. That is called electron affinity. Okay. An atom or group of atoms that has a positive or negative charge, those are called ions. Ions are atoms when they have an electric charge, either positive or negative. Okay. Phenomenon whereby valence electrons do not feel the full force of attraction from the nucleus because they're repulsed by those inner shell electrons. They're pushed away, they're shielded from the nucleus, is called the shielding effect. Okay. The ability of an atom to attract electrons when the atom is in a compound, that is electronegativity. That's why noble gases don't have electronegativity. It doesn't apply to them because they're never in compounds. Okay. Number six, energy required to remove an electron, that is the ionization energy. Number seven, how reactive a metal is, it's called the metallic character. Okay. Number eight, the electrons in the highest energy level, you guys should know this by heart by now, that would be the valence electrons. Valence electrons are electrons in the outermost or highest energy level. Okay. Number nine, half the distance between two nuclei of the same element when the atoms are joined together is called the atomic radius. And then number 10 and 11, you can have an ion with a positive charge, and that's called a cation, or you can have an ion with a negative charge, and that's called an anion. Okay. So when talking about electronegativity, it increases as you go up on the periodic table and as you go to the right, which it's backwards for you. So as you go up a group, electronegativity increases, and as you go to the right, electronegativity increases. Now, the exception to that is the noble gases. Noble gases do not, the rule does not apply to the noble gases when we're talking about electronegativity or electron affinity. So what element has the highest electronegativity? We're looking at the element that's highest on the periodic table and farthest to the right when you take out or exclude the noble gases, and that would be fluorine. Okay. Why do noble gases have low electronegativity? Because they have a full valence shell. They never want to bond with anything because their electron shells are full. Okay. Number 14, the figure below is a portion of the periodic table. Use it to answer the following questions. So which element has the largest atomic radius? Well, if you remember, atomic radius increases as you go to the left. So it would be the element on the far left, or lithium. Okay. Which element has the greatest electron affinity? That would be electron affinity increases as you go to the right, but you have to remove the noble gases when it comes to electron affinity. So that would be fluorine. Okay, so it's furthest to the right once you take out neon, because neon's a noble gas. Which element has the smallest electronegativity? Electronegativity increases as you go to the right, so the smallest one would be on the left, lithium. And then which one has the greatest ionization energy? That's going to be neon. Because ionization energy increases as you go to the right, and noble gases do have ionization energy. We can take those into account when we talk about that. Okay. Number 15, which element has the smallest atomic radius? Atomic radius increases as you go to the left, so it'd be whatever's over here, and that's argon. Which element has the smallest electron affinity? That is actually smallest electron affinity. That's a typo. That should say sodium. Okay. Oh, no, just kidding. My bad. Because noble gases have, the trend is that electron affinity increases from left to right, except for the noble gases. They don't have any electron affinity, so that would be the lowest. C, which element has the greatest electronegativity? That's going to be chlorine here, because it increases from left to right, but with electronegativity, just like electron affinity, we've got to take out the noble gases. So that's why chlorine has the highest. D, which element has the smallest ionization energy? It also increases from left to right, so sodium would have the lowest. All right, so we've practiced the trends on the periodic table within a period or within a horizontal row. Let's practice them within the groups. Which element has the largest atomic radius? Atomic radius increases as you go down a group, so from top to bottom. So francium, the bottom one, would be the biggest when it comes to atomic radius. Which element has the greatest electron affinity? Going to be hydrogen. Electron affinity increases as you go up. Smallest electronegativity also increases as you go up, so it's going to be what's on the bottom would be the smallest. And then the greatest ionization energy, it also increases as you go up a group from bottom to top, so that would be hydrogen, the greatest. Okay. Then over here, which element has the smallest atomic radius? Atomic radius increases as you go down, so the top one would be the smallest, fluorine. Electron affinity and electronegativity increase as you go up. So fluorine would have the greatest electron affinity and electronegativity. And then ionization energy also increases as you go up a group. So TS has the smallest ionization energy. All right, and lastly, we're almost done. Here is a section, a whole section of the periodic table, okay? And let's use it to answer the following question. So which element has the largest atomic radius? Atomic radius increases as you go to the left and as you go down. So the element furthest left and furthest to the bottom has the biggest atomic radius, NH. Smallest electron affinity increases as you go up and to the right. So NH would have the smallest electron affinity, okay? Greatest electronegativity is fluorine. It increases up and to the right, but this last column here, neon all the way down, these are your noble gases. So we have to leave them out when we're talking about electronegativity and electron affinity, okay? Greatest ionization energy is neon. Noble gases are fine when we're talking about ionization energy, and that's, I think, going to be the trickiest part of the exam, is remembering that we can use the noble gases when we're talking about ionization energy, atomic radius, all that stuff. But for electron affinity, for electronegativity, we cannot include the noble gases. Okay, we just have to pretend they're not there. Okay, smallest atomic radius also would be neon, because atomic radius increases to the left and down. So whatever's in the top right would be the smallest. Greatest metallic character, or how reactive a metal is, increases the same direction as atomic radius, so to the left and down. So that'd be NH. Smallest electronegativity would be down here, NH. Smallest ionization energy would also be NH. Least metallic character, so metallic character increases to the left and down. Whatever's up here in the top right is going to have the least, and that is neon. All right, so I hope that makes sense. One of the biggest parts of this exam that's coming up this week is the trends, understanding which direction atomic radius increases and decreases, and electronegativity and ionization energy, all those guys. You gotta know those. Okay, so I would study those for your final. If you guys need any help with anything or have any questions, feel free to email me. Good luck, guys.